We will create the following 3D model. As you can see right here, I have what could be a cube right here, and right here I have a circle, a semicircle hole in this direction, and right here I have a semicircle as well, hole in this direction with this magnitude. Right, so the first thing that we have to take into account here is the information within the engineering view, principally the information within the views. All right, as you can see right here, I have 3 different views, and actually 2 views, and one auxiliary, one section view. One thing that I should say right here is that this is not necessary. Why is that? Because this is as simple as just having to create one view with this, with respect of this axis, and one view with respect of this axis. All right, as you can see, with these 2 views is everything I need for me to create this 3D model. Maybe it's not that easy to see, but when we're creating it, I'll explain it later, right? This engineering draw was made by Luis Miguel Huérfano Garzón, and the second thing that we are going to take into account is the unit system that the engineering draw is given to us. In this case, I cannot find information about anything next to the dimensions, so I'm gonna look somewhere within the draw, and I cannot see anything. All right, for when this happens, I can assume that these are millimeters. This information of the unit system usually comes right here, taking into account the normativity for the draw, but it usually comes into a box that not only tells me the material, also tells me who did, or the person who did this engineering draw, the person who checked, the unit system, of course, the date, and some other aspects. So as I said before, I can assume that there's some millimeters, and we can start doing this engineering draw. The second thing that you have to take into account here is that we are going to start creating the 3D model using the sketch that contains the most information possible. In this case, that sketch or that view that contains the most information is this one. As you can see right here, I have 1, 2, 3, 4 dimensions. Right here I just have 1, and right here I have just 1. All right, so in Catia V5 we're going to start by clicking on SR, product, mechanical design, part design, sorry. This is going to be our tutorial 17, I think, tutorial 17 within the channel. Now we have access to the part design environment. I'm going to click on sketch, and I want this view to be my top view. So I'm going to select the XY plane. Right, we have access to the Catia V5 sketch environment, and all I have to do is to create a shape that looks like the one we have right here. Right, I don't really care about the dimensions yet. That is something that we're going to do later, right? So as you can see, this line that I just created has not been created horizontal, so this is something that I should solve later. And as you can see right here, what I did, and I want to do it again, is something like a trick, because all I have to do is to keep this click, maintain, and draw what could be a circle, right? And Catia is going to understand that I want to create a circle. For when I want to change the direction of that circle, I should click right here. That is going to ask me, okay, with respect of this point, of what point do you want to create the circle? So I'm going to click right here, for example. I want to change that point once again. I'm going to click right here. All right, so that looks good. Look good enough, right? So I'm gonna start creating the dimensions and the constraints for me to define the profiles. So as I just said, this has to be a horizontal line, and I've made this mistake once again on purpose, horizontal, for you to realize how to solve it. These two lines are not vertical as well. So I'm gonna select the two of them, right click, select objects, vertical. Right? This circle could be at any point. So what I'm going to do is to create one line. I'm going to say that this point has to be connected with this coincidence. And this point has to be connected with this coincidence. All right, so as you can see right here, I cannot move this line further than the constraints that I've just created. And as you can see, this circle is not created with respect of the middle. Why is that? Because as you can see right here, it is not defined. So what I'm going to do is to create one line for construction purposes right here, an axis line. And I'm going to click right here and right here. Right, then I'm going to select these two, taking into account the control key, so maintaining that key. I'm going to select this constraint definition tool, and I'm going to say that this has to be constant. As you can see, and as you may realize, I can do that either this way or right click, selected objects, and okay, there is no way for me to do that the way that I just thought. Oh yeah, I remember. As I did before, these two and coincidence is the same thing. All right, but this, as you can see right here, this circle is created with respect of the middle of the 3D model. All right, so as you can see, this point and this point should be connected. So okay, I did not select the point and sorry, the point of the line and the point of this circle. It's right here, and right here I have the other point. Constraint definition, coincidence, and that would be all. As you can realize, this is going to be taking into account this line. Then how do I do for me to say that this line has to be exactly at the middle between these two lines? Well, all I have to do is to create a symmetry line. So I select these two lines, taking into account the constraint option, the constraint tool, and allow symmetry line. Then all I have to do is to select the line that I want to be at the exact middle. So when I move this, everything is going to be moved, taking into account the constraint that I just created. All right, all it's left is to create the dimensions. So I'm going to start creating the same dimensions that I have right here, the 53, the 40, and this radius. So this, and this. Then what I'm going to use is this tool, edit multi-constraint. Bear with me while I change this, and then I explain what is happening. 12.5. All right, as you can see, this tool allows me to change all the dimensions without changing the shape of the profile that I just created of the sketch. So it is showing me in cyan the dimensions that I've just changed, in orange the dimensions that I'm currently changing, and in green the dimensions that I've not changed yet. Right, so this is equal to 40 and this is equal to 53. Preview. Okay. All right, everything looks good. There is something I should have done at the start of this creation of this sketch, and needs to verify the unit system that I'm using. I didn't do it because I'm sure that I'm working on millimeters, but this is something that you should do. Tools, options, parameters and measures, units. I right here have the unit that I'm using for the creation of this 3D model. I already knew that was millimeters, but you have to be sure of it. All right, so I have created this 3D model. I'm getting out of this sketch. Then I'm going to extrude it, taking into account this dimension, the 34. So all I have to do is to use the path definition option, the path definition tool, say that I want an extrusion of 34 millimeters. Okay, and that would be all. All right, the next thing that I have to do is to create this hole. So I'm gonna take this information and that would be all. As you can see, it is taking into account the other side of okay, better explain it, the perpendicular, sorry, the perpendicular axis with respect of the hole that we just did, this hole. So it is created with respect of this face, right? So all I have to do is to click on a sketch, select in this case the face, and now we have a perpendicular view with respect of this face, right, as you can see right here. So all I have to do is to create this radius of 27. So I'm gonna call this point within the sketch that I'm currently creating with this tool, projection. I've projected, but as you can see, it is going to be shown right here, this point, but I don't want that this point is shown. So all I have to do is to select this point and select this tool, construction standard element. Right, now that we have created this, I'm going to create a circle with respect of this point. But because I have already select this tool, everything that I do next is going to be created for construction purposes, as you can see. So all I have to do is to deselect it and once again create this circle. Or I can select the circle and deselect the option. Alright, this has a dimension of 27 of radius, so I change this to radius 27, enter, and that would be all. All I have to do is to create a pocket definition, so pocket definition tool, and I'm going to say that this has a length of 27, so 27, enter, and that would be all, guys. This is how you could have created this 3D model using Catia V5. Now, one thing that I just said is that this section view was not necessary. And I want to explain this once I have this 3D model. Why is that? Because right here, as you can see, when I get to the top view, it is showing me that right here I have a hole. right? And right here I have one square. I don't know if that is that has a circle or a rectangle or a square. All I know is that these lines are shown, and that means that I have right there a hole. But what happens if I get to this view? I think that could be this one. Okay, the other one. Tip back. Okay, it is going to solve the equation that I had before. This is not a square, this is a circle. And with those two views is everything I needed for me to create this 3D model. It is not necessary for me to create a section view within the engineering draw for me to show that. Alright? That is something that I wanna make clear. And that will be all, guys. As I said before, this is how you could have created this 3D model using Catia V5.